Welcome back to Third Inquisitive Kids for another video on cryptarithms. Coca plus cola equals an oasis. This probably means whenever you're thirsty, Coca-Cola is just like an oasis in a desert. Well, how would we solve this problem? Again, we have two addends added together to get a sum of 5-digit number. So because there are only two numbers being added together, the O is 1. And if O equals 1, then C plus C must equal a 2-digit number, or it can also get carried. So what can C be? C can either be 9, or 8, or 7, or 6, or 5. And A would equal 9 if something is getting carried. 8, 7, 6, 5, 4, 3, 2, or 1. Oh, it cannot be 1 because O is already 1. So what can S be? If you look at the hundreds column, S can either be 2 or 3. 妈妈，可以关这里的门吗？我这里我在录视频。关门。But if you think about it, S can only be 2 because when we look at the ones column, A plus A equals S, and nothing can get carried to this column. So S equals 2. And you might be thinking, well, then this is contradictory because O equals 1 and then A will also have to equal 1. But think about it. What other number when multiplied by 2 gets a result of a 2 in the ones place? That's right. A can also equal 6. So A is equal to 6. 6 plus 6 equals 12. We have to carry a 1 to the tens place. And since in the hundreds place, 1 plus 1 equals 2, and nothing gets carried, in the thousands place, the C each equal 3. 3 plus 3 equals 6. So now what digits do we have? 0, 1, 2, 3, all the way up to 9. 1 is already taken. 2 is already taken. 6 is already taken. If I is 0, then L is 6. If I is 4, L must equal 0, and so on. If I equals 7, then L would equal 3. If I equals 8, then L would equal 4. If I equals 9, then L would equal 6. Then L would equal 5. But we can first cross this column out because L can't be 1. O is already 1. And L also cannot be 3 because C is already 3. L cannot be 6 because A is already 6. So we have 3 possible solutions for I and L. And this would be our answer for this problem. Now we're on to problem 7, our next problem of this playlist. For no plus man plus no equals hand. No man, no hand. We can start off by listing out our digits from 0 to 9. By looking at this, I see that H must be equal to 1. How do I know that? Well, here we have 2 no's, right? 2 2-digit numbers. The biggest 2-digit numbers, 99 plus 99, added together will give us 198, which is only a 3-digit number. And the biggest 3-digit numbers added together. And so H, we can see that it's a carried number. It's a carried digit. And a 3-digit number plus a 3-digit number can carry a maximum of 1. In fact, any two numbers added together can carry a maximum of 1. So h must equal 1. Now we can rearrange the words a little bit. Instead of saying no man, no hand, we can say no, no man, hand. No, no man, hand. We can see that m plus a must equal a 2-digit number. And this 2-digit number has to have 1 as its tenths place. So what could m be? M could be 9, right? Or it can also be 8. Because now when we look in the tens place, we have 3 numbers being added together. And if we have 3 numbers being added together, they can carry a maximum of 2. So 8 plus 2 will still equal a 2-digit number. But as you can see, no matter what, so then what could A be? A could be 0, right? It could also be 1 because 9, if we have m as 9 and a 2 is carried, 9 plus 2 equals 11. A can also be, but knowing that h must be equal to 1, A cannot be 1. 1 is already taken. So A is 0. And if A is 0, and if this A is 0, then this A is also 0. It's the same for this A. Now, let me enlarge this a bit. When we look in the tenths place, n plus 0 gives us a number that gives us a number that ends with n also. And we would have to, and since now basically we only have 2 numbers being added together, n and n, only 1 can be carried. So knowing that if only 1 can be carried in order to result in 10, then m would have to equal 9. So m equals 9. What could n be? N, first of all, could be 0. It could be, but remember, a 1 or a 2 can be carried to the tenths place. So what could n be? N, of course, could be 0, but 0 is already taken. N can't be 2. N can't be 3. N, however, n can't be 4. N can't be 5. N can't be 6. N can't be 7. But n can equal 8. If we have 8 plus 8 to give us 16, and this 2 is carried, 16 plus 2 gives us 18, which means that n will still be 8. So now we know that n equals 8, and a 2 is carried to the tenths place, which means that in the ones place, these numbers, O plus 8, must equal a number that has 2 in the tenths place. So what could O be? O could be 7. O could also equal 6, but O can't be 5, or else that's too little. If O is equal to 7, 7 plus 7 equals 14, plus 8 equals 22. D would then also equal 2. If O equals 6, 6 plus 6 equals 12, plus an 8 is 20. But D can't be a 0 because A is already 0. So D can only be 2, which means O can only be 7. So our solution for this problem would be H equals 1, M equals 9, A equals O, N equals 8, O equals 7, and D equals 2. Here's problem 8, spot a top ghost. So we can begin by writing out our digits, 0 to 9. And now we have 3 addends being added together. Spot a 4-digit number, A, a 1-digit number, and top, a 3-digit number, added together to give us a 5-digit sum. So there must be a lot of carrying in this problem. And speaking of carrying, we can start to think about what is the max we can carry to each place value. Let's start from the right side. On the right side, we have 3 digits being added together. So our biggest digit, 9, times 3, this is the method you use to find the max of carrying a number. Times 3 gives us 27. And since 2 is in the tens place, it means that we can carry a max of 2 to the tens place. So it would be 0, 1, or 2. And now when we look at the tens place, we have O and O, 2 digits. So again, we take our biggest digit, which is 9, times 2, which gives us 18. So we can carry a max of 0 or 1 to the hundreds place. But remember, we might also have a carry digit from the ones place. And if a 2 got carried, 2 plus this 18 would give us 20. There is also a chance that a 2 is carried to the hundreds place. Again, we can do 9 times 2, which gives us 18 because there's 2 digits being added together. But remember, there's a chance of a 2 being added to this 18. So 18 plus 2, again, gives us our 20. And 2 is in the tens place. So we can carry 0, 1, or 2 to the thousands place. G is clearly a carried digit. So what could G be? Of course, G can't be 0, but it could be 1 or 2, right? So either a 1 or a 2 has to get carried to the 10,000s place. Now let's think about it. Is it possible for us to carry a 2 to the 10,000s place? Is it possible to get a 20-something? So now let's think about it. The biggest number S can be is only a 9, right? That's the biggest digit we have. Plus 2 or plus 1, any of these carry digits, will give us a 11 or a 10. And 11 and 10 both have a 1 in its tens place, which means that no matter what, G will always only be 1. So we have that down now. G equals 1, and a 1 is carried to the 10,000th place. So now, what could S be? S could be 9, or it could also be 8, because a 2 could be carried. And so H could be 0 or 1 from the 10 and the 11. But since 1 is already taken by G, H could only be 0, and we can also cross out the 0. So S could now be 9 or 8. Let's leave it at that for now. When we go back to the ones place, we see T plus A plus P gives us something that ends with a T again. So what would happen if T equals 2? If T equals 2, it's not possible for us to get a 22, and it's not possible for us to get a final sum of only 2. So if T equals 2, then the sum of the ones place would be a 12. And so A plus P, would equal 10. If T equals 3, same thing. A plus B also equals 10. It's the same thing when you increase T. A plus P will always equal 10. They'll have to equal 10. And we're starting to run out of space. So now we have our possibilities out. But based off of this chart, we can see that only a 1 can be carried to the tens place, so we can cross out the 0 and the 2. Now when we look at the tens place, we see that 1 plus O gives us S. Since O plus O must be an even number, 1 added to an even number will always give us an odd number. So S must be an odd number. And we already know that S could either be a 9 or an 8. Out of these two digits, 9 is the odd one. So S would equal 9. And if S equals 9, then O plus O would give us 8. And that means that 1 O is a 4. So now 4 and 9 are already taken. And because in the tens place, we only add up to 1 9, we can't carry anything to the hundreds place. That P plus T must give us 4. And because S equals 9, then a 1 must be carried to the thousands place. So P plus T gives us 14. Now we've narrowed it down a lot. All we have to do is do trial and error for the values of T and A and P. If T is 2, A plus P would have to equal 10. And with the digits we have left, only 3 and 7. If t equals 2, p would have to be 12. T cannot be 2 or 3. Why? Because if t equals 3, let's say, in the hundreds place, we have to add up to be 14. P can only be a one-digit number, though, and so t would be too small. If t equals 5 in the hundreds place, p would equal 9, but 9 is already taken by our s. So now t could only be 6, 7, or 8. If t is 6, then p would be 8, and a would be 2. A equals 2, p equals 8. That could work out, but we still have to test out the other ones. If t equals 7, then p will also have to be 7 in the hundreds place, but that wouldn't work out because they are different letters. If t is 8, then p would have to be 6. But when we check it again in the ones place, a would have to be 4. But 4 is already taken by our letter O. And that leaves us with only one possible situation, which is t equals 6, and a equals 2, and p equals 8. So that is our solution. Let's rewrite our solution a bit more clearly. G equals 1, S equals 9, H equals 0, T equals 6, A equals 2, and P equals 8. That is our solution. And here's our 9th cryptarithm of this playlist. Moses meets Salome. We can first write out our digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Based off of our observations, we can see that there are 2 numbers being added together. And because there are only 2 numbers being added together, this carried S in the beginning must be a 1. So all the S's are 1s. S equals 1, and we can cross out 1. And because S equals 1, when we look in the ones place, E will have to be 2. And so what could M be? We know that M definitely cannot be 0. M cannot be 3. M cannot be 4. M, however, can be 5 because 5 plus 5 equals a 2-digit number. What about M equals 6? M can also equal 7 or 8 or 9. If M equals 5, A would equal 0. And this T here would be 3. And then the O's would have to be 3 and 3. But then when you look in the thousands place, 3 plus 2 gives us 5. But M and L cannot be 5 at the same time. So 5 does not work for M. Now what if M equals 6? T would equal 4. O would equal 3. L would equal 5. And A would equal 2. So M could be 6. What if M equals 7? Well, then T would equal 5. A would equal 4. O would equal 3. But we can't have L and T being 5 at the same time. So M cannot be 7. If M equals 8, T would be 6. And O would be 3. L would be 5. And so A would be 6. But we can't have A and T being 6 at the same time. So M cannot equal 8 either. What if M equals 9? If we have M equals 9, then T would be 7. O would be 3. And L would be 5. And A would equal 8. So M could be either 6 or 9. So when we go back to M being equal to 6, all the M's equal to 6, T would be 4, A would be 2, O would be 3 and 3, and L would be 5. Let's see if this makes sense. Plus 6, 2, 2, 4, 1 equals, let's see what we get, 2, 6, 3, 5, 12. So this does make sense. What if when M equals 9? When M equals 9, T equals 7, and A equals 8, O equals 3, and L equals 5. Does this make sense? 9, 3, 1, 2, 1 plus 9, 2, 2, 7, 1 equals 2, 9, 3, 5, 18. Then what is our solution? How would we express it? In both of these examples, L equaled 5 and O equaled 3. The letters A and T were the ones who changed. So when M equals 6, A equals 2, and T equals 4. When M equals 9, A equals 8, and T equaled 7. So that was our solution for this problem. I hope you enjoyed it, and be sure to come back for our next Cryptarithm. Again, we have two numbers being added together to result in a number with a greater place value, which means that E must be our carry digit, so it's 1. And so E would equal 1. Then we see something in the tens column. S, you might think, is 0. 0 plus 1 equals 1, right? So S equals 0. But there are many ways to prove that S does not equal 0. One of the ways is if S equals 0, then N will also have to equal 0. And that cannot be true. And if you think about it, if S equals 0, then we won't be able to carry this E. So S is not 0. Then what can S be? S would have to be a 9. Because if S equals 9, we can carry a digit here to still make it 11. But since we result in 11, we have to carry a 100 to the 100th place. Then N would equal 8. L would be 3. And as you can see, we can find the rest of the problem. T would be 4. So this was very quick. Let's check our answer. 4199 plus 9119. Let's see what we get. 18, 11, 3, 13. And that's exactly indeed what we got. So our answer would be E equals 1, S equals 9, N equals 8, L equals 3, T equals 4. And this is our solution.